Hello everyone, welcome back to this lecture series on the thermodynamics. This is Dr. Rahul Srivastav, Assistant Professor, Department of Physics, Bhopal School of Social Sciences, Bhopal. As we have discussed in the first lecture of this series that we will have the proper description or the understanding of how our vehicle's engine or the petrol or auto engine actually works. So this is what our today's topic is, and it is a final conclusion of this particular section of thermodynamics, that is the working of an heat engine. That is the type of that heat engine is the petrol engine, or it is also known as the auto engine. So today's plan of talk, we will start with the brief description about the heat engine, as we have covered in the third lecture about the details of heat engine. And today we have some brief discussion of it, and we will go detailed on the auto engine or the petrol engine. It is one of the type of heat engine. Then after we will have the 4 strokes, the basic 4 strokes that is required for the working of an auto engine, and these are the charging strokes, compression strokes, followed by the working and exhaust stroke. So let me start with the brief description of the heat engine. That heat engine is basically an engine which continuously convert heat into mechanical work. So whatever the work done, we are having the rotation of a wheel or lifting a weight by a heat, is basically the working of an heat engine. So this heat engine continuously work in a cyclic process. So what is the meaning of the cyclic process? It continuously take energy from the source and convert it into the mechanical work, whatever the work we want, and that the waste heat or the waste gases of this engine removed by a sink portion. And after removing this, it is completely restarted engine for the next cycle. So it again take energy from the heat, work and remove from the sink, again take energy from the source, working and removing from the sink. So this is a continuously cycle which is followed by an heat engine. So it is also known as the cyclic process of an heat engine. So let me have some also details about this heat engine, is that it is having 2 basic types. First one is the external combustion engine and followed by the internal combustion engine. So first one, that is the external combustion engine, is that there is the energy which is providing in the piston for the movement of a wheel or a cyclic process, which we are providing from the external or the outside. So this is known as the external combustion engine because of this external burning of fuel or the steam that is coming from the outside. So let me take an example of the external combustion engine, is the steam engine that has been previously. We all know that in the ancient time the engines of our trains basically runs on this external combustion engine, in which we are having the steam of water by some burning process, and this steam actually move our piston. So because of this motion of piston, we are having the rotation of wheels and engines are going forward. So this is what the external combustion engine is. But nowadays we are having the internal combustion engine, because there are some problems with the external combustion engine. They are having the speed limits, the amount of speed we require, that is also not capable provided by the external heat engines. So we are having the another one, or the greater application one, is the internal combustion engine, and that are, as its names imply, that they are the engines in which fuel combustion is done internally in the cylinder of an engine. So a cylinder is basically a place where the fuel we put on it, and this fuel get burned and provide us the amount of force that is required for the motion of an wheel or for the motion or rotation of an piston. So because of this, the combustion process is going inside the chamber or inside the cylinder, so it is known as the internal combustion engine. So in the case of this particular engine, we take petrol, diesel, or sometimes liquid petroleum gas, that is the LPG, and compressed natural gas CNG as an fuel that actually get burned there and provide the amount of heat that is required for the rotation of wheel. So this internal combustion engine is basically having 2 types, that is the auto engine or the petrol engine. Since we are using petrol as a fuel, input fuel, so it is known as the petrol engine, and the second one is the diesel engine, in which we use the diesel for the burning process. Since our particular today's topic is dedicated about the petrol engine, so we will have the detailed focus on it. Diesel engine we will further discuss on the next following lectures. So the first one is the Otto engine or the petrol engine. Since I have already told you that we use petrol as a fuel for the burning, and the working cycle of this particular engine has been given by Butte and Roches in 1862. But this is the incomplete structure that has been given by them and has been completed and refined by Otto in 1876. So on his name, this particular engine is also known as the Otto engine. And since we are using the petrol, so it is also known as the petrol engine. So multiple names we are having for this engine. And in this type of engine, the absorption heat is done at a constant volume. So the volume of a particular cylinder is not getting changed, it is remain constant. So it is also having the mixture, since because of we are having constant volume, so we can have the mixture of air and petrol there. So the combination of air and petrol can be used as a fuel for the burning process, and this mixture has been we are having from the compressor also. So this is why the engine is also known as the petrol engine, and it is having 4 strokes that we are going to discuss in the next slides. That 4 strokes basically are the 4 steps for achieving the one cycle, and these strokes, and we are very much familiar with this name, that is the 4-stroke engine. It's also a kind of Otto engine or petrol engine. So let me start with the description of this particular cylinder that as we can see in the image. This particular is a cylinder, we can see it, and this cylinder is continuously having some fuel burning process and also the moving of piston. So in Otto engine, there is a cylinder which is fitted with, and we are having the piston which is fitted inside it with a clamp. So this piston is continuously moving in this cylinder and creating a vacuum air. So there cannot be any filling from this particular side. We can have only input and output on this region. And also we are having 2 bulbs here. This particular one is the input one, the blue one, we can see it, and this the upper side, and we can see it that the red one is coming from it and releasing these waste removed. So these are the input, and followed by the upper one is the output or outlet bulb, which is continuously, this outlet bulb is continuously removing waste heat. So the process of opening and closing of these bulb is basically controlled by this motion of this piston. This piston is continuously since moving in motion. So this motion is creating the opening and closing of these bulbs, and this piston is basically connected with a crank, and this crank is connected to a wheel of a vehicle. So vehicle's wheel is connected to this piston. So we can have this rotation of our wheel by this particular motion of piston. Alright. So this particular arrangement can also have additional anomaly that is known as the carburetor. This particular device is basically for mixing, and that mixing is going for the petrol, and that with the air. So the mixture of air and petrol is creating by the carburetor, and this carburetor continuously doing it and providing inlet to this particular piston or a cylinder via inlet bulb. So this mixture can easily get burned, and here we can have this mixture, the burning process via a spark, and we have connected a spark plug. As we can see that this particular, the yellow one will create the spark here. Yes, we can see it, that spark is creating by this particular plug, and this is known as the spark plug, which is continuously burning the mixture that is coming from the inlet valve, and actually this is igniting it, so it can go for the or the particular piston can go in the motion. After that ignition, that the fuel has been burned, the heat has been generated, and this creates some waste energy or waste heat there that has to be removed, some carbon particles, and also that has been removed by this outlet valve. So this particular is releasing the waste amount, and the piston is restored for the next cycle. So this is the complete cycle or the working of an Otto engine. As we can see, we put fuel on a fuel tank, whether it is petrol or diesel, and this fuel tank is basically we can say it as a source or the fuel provider. Then the carburetor continuously adding fuel. Fuel means adding water vapors, adding petrol vapors along with the air mixture. So it is mixing air and petrol vapors, and they continuously filling this particular chamber, and then after we are having the burning process. So I will describe this in detail in the following slides, that are the various strokes of this engine. So we can say this is the 4 steps or the 4 strokes of an Otto engine. The first one is the charging stroke. As we can see, the fuel is getting filled in it as the image is showing. And also the second one is the compression stroke. The fuel will get compressed on it. The third one is the working stroke. Here we will or the a particular spark plug will provide a spark to it, and the last one is the exhaust stroke, in which the waste energy will release from it. So as we can see in the image, the fuel is getting filled, that is compressed, the sparking process, working substance, and this removal or the exhaust stroke. So let me start with the first step, or the first stroke is the charging stroke. So in this particular stroke, the piston moves downwards. It is a constant image, not a GIF. So you can see via this green arrow that piston is going downward. So we can have this particular region as an empty. So this particular inlet valve get opened, and due to this, there's inlet valve which open. So the mixture of petrol vapors and air that is coming from the carburetor fills in this particular cylinder for the next step. So in a charging step, we can say that the particular inlet valve is getting open, and the fuel is getting filling in this particular region, and that is ready for the further steps. So the next one is the compression stroke, in which since it has been filled, now the piston will go upward. In the previous step, the piston is going downward, so it is getting empty. Now it is filled. Second one is the compression process. So the air mixture and petrol vapor that is coming from the carburetor has to be compressed. So this piston is now going from the upward direction and compressing these mixture continuously, and because of this compression, the particular temperature of this chamber or the fuel is achieving the value 600 degrees Celsius. So we can say that this because of this compression process, that particular chamber is completely get heavy temperature for it, and that's what we are looking for our stroke, or for the some spark for our vehicles movement. So because of this compression process, we have achieved some temperature that is around 600 degrees Celsius, and then after it is ready for get burned. Once we provide a stroke to it, it gets burned, means it get a heavy ignition of fuel there. So at this instant, spark is produced in this spark plug, and mixture is getting start burning. So this particular mixture is going to burn. Now the third one is the working stroke, in which if that spark generates from the spark plugs, this fuel gets sudden burned, means sudden get burned. So it creates a lot of amount of heavy temperature here, that is around 200 degrees Celsius temperature. So because of this pushing or this hardness of temperature, this particular piston again go towards downwards with some heavy force, and that force or pressure inside is created something around 1 lakh Pascal there. So we can imagine the amount of pressure inside this chamber, and that particular piston go with some heavy shock which creates a huge or high amount of velocity or the velocity there. So due to this high pressure and temperature, vapor on this cylinder expand adiabatically and in a high pressure region. So the piston moves out with large velocity, and this large velocity creates some heavy rotation of our wheel rapidly there. In this stroke, the work is done by this engine. That particular work done is the rotation of wheel that we have achieved. So this is known as the working stroke because of this name. And now the temperature of pressure of this once we have the rotation of our wheel is complete there. So this again going downwards. So temperature and pressure is going downwards. It is getting decreased, and this the waste amount of this temperature and pressure has to be removed outside. So the last stroke we are having is the exhaust stroke, in which the piston reaches at the end of the cylinder, and the the outlet valves get open. Once it gets open, the piston coming back towards the upper side and it escapes the gases inside it, the base amount of gases, base amount of temperature and energy which has been filled in this particular region, that has to be removed via this outlet valve. So it is known as the exhaust stroke, and at the end of this the piston again back towards the downward, so it is ready for the next cycle, and we can say that it is reset for the next further process. So this is continuously doing the cyclic process. So as I have defined you all 4 strokes of it, so we can see final the GIF image of our Otto engine and the working of Otto engine. As the numbers is going, the first number is showing the input, and this is filling, the blue one is filling petrol in it or the mixture of it. Second one is we can see it the compression process. Third one is we are seeing the spark process, and the fourth one, that is releasing the waste amount, that this one, that the valve open and the release. So you can see it 1 2 3 4, and the first one is showing the first stroke, that is the inlet petrol in it or the charging stroke. Second one is the compression stroke, the fuel or air mixture is getting compressed there. The third one is the in the burning process or the we can say that the working stroke, and the last one is the exhaust stroke. So these 4 are the basic steps or stroke for the rotation of an wheel. So this is what the working of an Otto or an petrol engine is. And for this today's lecture, this is Dr. Rahul Srivastava from B.Sc Bhopal signing off. Thank you so much.